gravity of a lamina occupying a region R in the horizontal xy plane is the point denoted by x bar, y bar, such that the effect of gravity on the lamina is equivalent to that of a single force acting at x bar, y bar. If x bar, y bar is in the region R, capital R, then the lamina will balance horizontally on a point of support placed at x bar, y bar. Now, the center of gravity x bar, y bar of a lamina is calculated by using the formula x bar equal to double integral over R x delta xy dA divided by double integral over R delta xy dA, and y bar is equal to double integral over R y delta xy dA divided by double integral over R delta xy dA. And here we know double integral over R delta xy dA denote the mass of the lamina. Okay. Now, here we can denote the numerator of x bar as my and the denominator by capital M. And here my means my equal to double integral over R x into delta xy dA. That is the first moment of the lamina about the y axis. Okay. Similarly, we can denote y bar is equal to mx divided by m. And here mx is the first moment of the lamina about the x-axis. Okay. So, here we have x bar is equal to my by m, and this is same as double integral over R x into delta xy dA divided by mass of the region R. Similarly, we have y bar equal to mx by m, and that is equal to double integral over R y into delta xy dA and divided by mass of the region R. Now, using this formula, we can find the center of gravity of an inhomogeneous lamina. Okay. Now, let us move to one example for finding the center of gravity of a inhomogeneous lamina. So, first question, find the center of gravity of an center of gravity of the triangular lamina with the vertices 0, 0, 0, 1 and 1, 0. Also, the density function is given as delta xy equal to xy. Okay. So, here corresponding to this problem, the mass of the lamina we already calculated in the previous video. Okay. So, you can watch that video again for finding the mass of the lamina. So here we can just write the formula. M is equal to double integral over R delta xy dA, and this is equal to double integral xy dA over R. Now you can draw the corresponding region. Okay, now this is the point 0, 0, this is 1, 0, this is 0, 1, and this line represents x plus y is equal to 1, and the region of integration is this one. Now for calculating the integral, you can consider the region as a type 1 region. So you can draw a vertical line. After that, you can find the upper and lower limit of x and y. Okay. Now the mass M equal to double integral over R delta xy dA, and here double integral xy dA over R. Now you can consider this as xy into dy into dx, and here you can see that y varying from 0 to 1 minus x, and x varying from 0 to 1, and the corresponding answer is 1 by 24 that we already calculated. Okay, now we can find capital My and capital Mx, that will give you the moment of the lamina. So first we can find the moment of the lamina. Moment of the lamina about y-axis, that is calculated by the formula My is equal to double integral over R x into delta xy dA. This is equal to double integral over R x into xy dA, and this is equal to integral from 0 to 1, integral from 0 to 1 minus x square y dy dx. Okay, now you can integrate this. So this is equal to integral 0 to 1. Now first we can integrate with respect to y. So x square is a constant. So x square into integral y, that is y square by 2, and here y varying from 0 to 1 minus x dx. Now this is equal to integral from 0 to 1 x square, here 2 is a constant, then 1 minus x the whole square dx. Now this is same as 1 by 2 into integral from 0 to 1. Now you can expand this, x square minus 2x cube plus x raised to 4 dx. Now this is equal to 1 by 2 into integral x square is x cube by 3, then integral x cube is x raised to 4 by 4, integral x raised to 4 is x raised to 5 by 5, and here x varying from 0 to 1. So that is equal to 1 by 2 into 1 by 3 minus 1 by 4 plus 1 by 5. Okay, so this is equal to 1 by 2 into 1 by 30, that is equal to 1 by 60. Okay, similarly we can find the mass of the lamina about the x-axis, and the formula is given by Mx equal to double integral over R y into delta of xy into dA. Now you can substitute for delta xy. So this is double integral over R y into xy into dA. As in the previous problem, here also we can take y xy dy dx. and here y varying from 0 to 1 minus x varying from 0 to 1. Now you can integrate. Then after integration, the answer will be 1 by 60 as in the previous case. Okay, so we can calculate our x bar now. What is the formula for x bar? X bar is equal to my divided by m. So the answer is 1 by 60 divided by 1 by 24, that is equal to 2 by 5. Similarly, y bar is equal to mx divided by m, that is equal to 1 by 60 by 1 by 24, and that is equal to 2 by 5. So the required center of gravity of the inhomogeneous lamina is x bar y bar equal to 2 by 5 comma 2 by 5. Okay. So this is the method of finding the center of gravity of a inhomogeneous lamina. So a single force is acting at a x bar, y bar. Okay. Okay, thank you all.